Okay, let's now take a look at the final part for electrophilic sub. The question that we're dealing with is how if methylbenzene and mononitrobenzene undergoes further electrophilic substitution. Say, for example, with the electrophile Cl+. Let's take a look at the what are the possible isomers that can be produced when methylbenzene react with Cl+. So Cl+ could go to position 2, indicated by these two arrows here. Okay, or it could form, it could go to position 3, okay, carbon number 3, indicated by the two red arrows as well. Or otherwise, you can actually go to position 4. So what we need to know is that the methyl group that's bonded to benzene is electron releasing. Because it releases the electron, the otherwise homogeneous electron cloud that's distributed in benzene will actually be polarized into a shape as such, as indicated down in this blue blot here. So you can see that the electron density, all right, around this carbon number 2, carbon number 4, and carbon number 6 would actually be higher. Hence, as a consequence, the methyl group is deemed to be what we call a 2,4 director. Okay? Because it directs the electrophile to position 2, indicated down on these two sides, or position 4. So let's take a look at the nitrobenzene. For nitrobenzene, if you take a look at it, conversely, the nitro group is now electron withdrawing. So you can see that the electron density of the electron cloud is actually polarized in a manner such that the main bulk of the electron density is at carbon number 3 and carbon number 5. So in this case, we could now say that the nitro group is a 3 director because it actually directs the electrophile to position 3, as indicated by the two orange arrow. So the purpose for this part of the discussion is to understand the impact of all these side chain on where the next electrophile is more likely to be bonded to the carbon in the benzene ring. So to do that, there's actually in the data booklet that we'll be using. So let's try and take a look at the table. This is a table that's provided in the A-level data booklet. What it means is that G is the existing side chain that's already bonded on the benzene. Then the electrophile is coming in, and the question is that where does this electrophile goes? So let's take a look at example 1. If you look at actually your ethyl benzene, ethyl group is an alkyl group. Because it's an alkyl group, it is actually a 2,4 director. Hence, as you can probably see, you realize that the 2,4 when bromines is at position 2 and position 4 is when they are actually the major product. So so this bromine here is actually bonded to the carbon number 3, is actually of a minor product. And do bear in mind that these are auto, meta, and para represents that the auto means is 2, meta means is 3, and para means is 4. All right. So that indicates where the bromines is actually bonded to. Finally, to note is that we expect this to be the higher percentage. This will be produced in larger percentage than position 2. The reason is because that in position 2, the ethyl group and the bromine group are actually of close proximity to each other. So there is greater steric hindrance and hence higher strain energy. And therefore, it's actually less stable. So hence, because of this, is produced with a lower percentage. Next piece of information to look at is the reactivity of the ring compared to benzene. So when they say activated, what it means is that in the presence of the alkyl group, all right, is the benzene ring more electron rich or less. When you see the term activated, means it is more electron rich, and therefore we expect the reaction rate to be faster. And if you remember earlier when we mentioned that your alkyl group is electron releasing, that also helps to explain why the benzene ring is electron rich, which in short, all the groups that's down here is expected to be electron releasing with respect to the benzene. So let's take a look at another example. The other example to look at is actually your bromobenzene. All right. So if I have a bromobenzene, I'm going to add on a nitro group. So let's take a look at the table. So bromine is here on the table, so it's a 2,4 director. So it's not surprising that this is actually the major product. P, as I repeat, P bromo is because it's para. So P also represents position number 4, while O is auto, so it represents position number 2. And final example to look at is actually your phenol. So let's take a look at what happens if the existing side chain becomes an OH. So OH is actually here, all right? So it is also a 2,4 director. As you can see down here, the methyl group goes to position 2 and 4.